Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics MMP paper first. Okay. In the last class we discussed about the Bessel functions and its solutions. Today we are going to discuss some formulas. That formula is recurrence formulas. So total formula is 6 formulas. So we are going to prove this formulas one by one. Okay. So first one, that is x jn prime is equal to n jn minus x jn plus 1. Okay. So we already derive this jn, that is Bessel polynomial functions. So this jn is equal to summations over r is equal to 0 to infinity minus 1 power r divided by r factorial gamma n plus r plus 1 into x by 2 power n plus 2r. Okay. This is the polynomial Bessel polynomial functions that we already derived. So this jn, if we differentiate with respect to the x, then jn prime is equal to summations over r is equal to 0 to infinity minus 1 power r divided by r factorial gamma n plus r plus 1, and here is a x. So if I differentiate with so it is n plus 2r into x by 2 power n plus 2r minus 1, okay, by the definition of the differentiation. So now if I split this n plus 2r in the two terms, this total expressions, if I write in the two terms, that is like this n is take out the outside the summations, so it is n summations minus 1 power r divided by r factorial gamma n plus r plus 1 into, sorry, here is a 1 by 2, okay, after the differentiation. So x by 2 n plus 2r minus 1, okay, this n take out the outside and into 2, this 2 is here, n by 2, okay, and one more term, that is plus, this plus signs, summations minus 1 power r into 2r, okay, this 2r is here, divided by r factorial gamma n plus r plus 1 into x by 2 power n plus 2r minus 1 and 2, okay, this half is here. So this half 2 and this 2 will be cancel out, okay. So this is expressions. So if I multiply to this jn, this is jn primes, okay. So if I multiply to this jn prime to the x with the x, so it is like this, x jn prime is equal to n summations r is equal to 0 to infinity, so it is minus 1 power r divided by r factorial gamma n plus r plus 1 into x by 2 power n plus 2r minus 1 n plus r plus 1 into x by 2 n plus 2r minus 1, and if I multiply to this jn, so it is x. I am right here. It is okay. Plus 2r minus 1 into x by 2 power 1. Okay, this half I take out the here, this half, and the x is we multiply with this jn. So power of this x by 2 is 1, and here is a minus 1, so this plus 1 and minus 1 will be cancel out, and these things, this is as it is, second terms, that is summations minus 1 power r divided by r factorial gamma n plus r plus 1 x by 2 n plus 2r minus 1. Okay. So this total expressions, if I write here, okay, x jn primes in summations minus 1 power r divide r factorial gamma n plus r plus 1 into x by 2 n plus 2r. Okay. So this minus will be cancel out. Okay. Here is a plus 1 and minus 1s. So power remains n plus 2r plus second terms, that is summations. Now here summations r is equal to 0 to infinity for the first, and here is r is equal to 1 to infinity, like this. Okay. So minus 1 power r, this r by r factorial we can write r minus 1 factorial gamma n plus r plus 1 into x by 2 n plus 2r minus 1. Okay. So here I am going to put this r minus 1 is equal to s. Okay. So this expressions, this n and this expressions is nothing but the jn. Okay. Summations or r is equal to 0 to infinity minus 1 power r divided by r factorial gamma n plus r plus 1 into x by 2 power n plus 2r. Okay. So this is expression for the jn. So we can write x jn primes is equal to n into jn. Okay. For these expressions I am going to write this jn plus, now if I put the r minus s, r minus 1 is equal to s, so this r is equal to s plus 1. Okay. So summations here, summations over s is equal to 0 to infinity, because we change this r in the term of the s. Okay. So that's why this summation also change from 0 to infinity, minus 1 this r is equal to s plus 1 divided by r minus 1, that is s factorials, and this n plus r plus 1. So if I put the r is equal to s plus 1, so n plus s plus 2. Okay. So gamma is n plus s plus 2. Okay. And x by 2 into x by 2 power n plus 2r. Okay. So it is 2s plus 2 minus 1. Okay. So this minus 1 plus 2 minus 1 will be plus 1. Okay. So this thing is plus 1. Okay. So this is expression for the second term. So x jn prime is equal to n into jn plus summations. Now this minus 1 power s plus 1, we can write minus 1 power s into minus 1 power 1. Okay, so minus 1 power s into minus 1 power 1, these things we take out here outside to the summations. Okay, so this plus will be changed to minus. Okay, so I am right here the minus s is equal to 0 to infinity minus 1 power s divided by s factorial gamma n plus 1 plus s plus 1. We can write like this. Just split this to 1 plus 1. Okay, so this n plus 1 plus s plus 1 into x by 2 power s factorial gamma n plus 1 plus s plus 1 into x by 2 n plus 1 plus 2s. Okay, so these expressions we can write is something missing. X is here, that we already multiply here x. Okay, so that's miss. This x we multiplied, so x is here, so it is equal to n jn, and this expressions we can write minus x into jn plus 1. Okay, for this expressions we can write jn plus 1. Okay, so this is first formula, that is x jn prime is equal to n into jn minus x jn plus 1. Okay, so this is the first formula, first recurrence relations. Okay, that is x jn prime is equal to n into jn minus x jn plus 1. Okay. Now let's solve the second one. X jn prime is equal to minus n jn plus x jn minus 1. Okay. So same, we know the Bessel polynomial functions, that is jn is equal to summations r is equal to 0 to infinity minus 1 power r divided by r factorials gamma n plus r plus 1 into x by 2 n plus 2r. Okay. So just differentiate with respect to the x. So jn prime is equal to summations r is equal to 0 to infinity minus 1 power r n plus 2r divided by r factorial gamma n plus r plus 1 into x by 2 n plus 2r minus 1. Okay, so if I multiply to this jn prime, so with the x, so x into jn prime, here is a half. Okay, so I am right here. Okay, so summations r is equal to 0 to infinity minus 1 power r divided by r factorials. If I multiply x, so x by 2. Okay, and here is a x by 2, this minus n. Okay, n plus r plus 1 n plus 2r. These things we can write like this. Okay, so this n plus 2r we can write 2n plus 2r minus n. Okay, so into x by 2 n plus 2r minus 1, and this 2 and this x we can write x by 2 power 1 plus 1. Okay. So this plus 1 minus 1 will be cancelled out. So power for this x by 2 will be n plus 2r. Okay. Okay. So now just split these brackets 2n plus 2r and the minus n. So these expressions like this: x j n prime is equal to summations r is equal to 0 to infinity minus 1 power r 2n plus 2r divided by r factorial gamma n plus r plus 1 and into x by 2 n plus 2r, and this minus n summations r is equal to 0 to infinity minus 1 power r divided by r factorial gamma n plus r plus 1 into x by 2 power n plus 2r. Okay, this just split this 2n plus 2r and the minus n. So this minus n is here and 2n plus 2r is here. Okay. Now take out the commons 2r from this brackets. Okay. X j n prime is equal to summations over r is equal to 0 to infinity minus 1 power r divided by r factorial 2 into n plus r gamma n plus r plus 1 into x by 2 n plus 2r. Okay. And the minus n summations r is equal to 0 to infinity minus 1 power r divided by r factorial gamma n plus r plus 1 and the x by 2 n plus 2r. Okay. So if you observe these expressions, so this is nothing but the jn. Okay. So we can write minus n into jn, okay, for these expressions. Okay, so here is a minus n into jn. Now here, if from this we can take out the commons, that is x by 2. If I take out common from this x by 2, so it is x by 2 summations r is equal to 0 to infinity minus 1 power r divided by r factorials gamma n plus r plus 1 2 into n plus r into x by 2 n plus 2r minus 1. If I take out the common this x by 2, okay, if I multiply to this thing, so same expressions you can get. Okay, minus n into jn. Okay, so this 2 and this 2 will be cancel out, and the x summations r is equal to 0 to infinity minus 1 power r. Now this n plus r divided by gamma n plus r plus 1, we can write 1 by gamma n plus r. Okay, so these things divided by r factorial gamma n plus r. Okay, for this n plus r divided by n plus r plus 1. Okay, and these expressions, that is x by 2, we can write n minus 2r minus n into Jn. Okay, so just this n plus r we can write like this: n minus r plus r plus 1. Okay, so it is same n plus r. So this total expressions we can write this is equal to x jn prime is equal to x jn minus 1 minus n into jn. Okay, so for this expression we can write jn minus 1, and this x is multiplied to these things, and minus n into jns. Okay, so this is second formulas, recurrence formulas for this Bessel functions. Okay, now third one, that is 2jn prime is equal to jn minus 1 minus jn plus 1. Okay, so just add these two formulas, we can find this first and second formula, that is x jn prime is equal to n jn minus x jn plus 1, and another, that is x jn prime is equal to minus n jn plus x jn minus 1. Okay, so if I add these two formula, so we can find this adding, this is first, second. Okay, so we can find 2x jn prime is equal to, this will be cancelled out, and minus x jn plus 1 plus x jn minus 1. Okay, so it just cancel this x, so it is 2 jn prime is equal to jn minus 1 plus, sorry, minus jn plus 1. Okay, so this is second one. Similarly, we can find this fourth one by subtracting these two formulas. Okay, so so I am not going to prove this fourth one. Okay, just subtract these two formulas, so we can find this fourth one. Okay, so now see the fifth formula: d by dx into x minus n into jn is equal to minus x power n into jn plus 1. Okay, so from the first recursion formula, that is x jn prime is equal to n into jn minus x jn minus 1, sorry, jn plus 1. Okay, so multiply to this formula with the multiply x minus n minus x power minus n minus 1, okay, to this formula. So this become x minus n minus 1 into x jn primes is equal to x minus n minus 1 into n jn minus x power minus n minus 1 into x jn plus 1. Okay, so here power for the x is 1. Okay, so this minus 1 and here 1 plus 1 will be cancelled out, and these things become minus x power minus n, okay, into jn primes is equal to x minus n minus x power minus n minus 1 into n into jn minus, here is also same things, this minus 1 and plus 1 will be cancel out, so this become x power minus n into jn plus 1. Okay, Okay, so you can write x minus x power minus n into jn prime minus x power minus n minus 1 into n jn is equal to minus x power minus n into jn plus 1. Okay, so these expressions we can write d by dx x power minus n into jn. Okay, because this jn is also function of x, so we can differentiate with respect to the x, is equal to minus x power minus n into jn plus 1. Okay, so this is fifth recursion relations for the Bessel functions. Now sixth one also same things. Here multiply 6 formulas. Okay, last one, that is 6 d by dx power d by dx into x power n into jn is equal to x power n into jn minus 1. Okay, so this is sixth formula recursion relations. So same here, just multiply to this first, that is x jn x jn prime is equal to minus n jn plus x jn minus 1. Okay, so by using the second recursion relations and multiply to this with the x minus n x plus, okay, multiply to this x power n minus 1, so we can find this 6 1 relations. Okay, so we can find this x power n into jn minus 1. Okay, I am not going to prove this, it is very easy, just multiply to this x power n minus 1. Okay, so okay, let's stop here. We will discuss in the next lectures.